as far as I remember, breakdown, right? Yeah, we finished or we started breakdown? We just started breakdown. So we were studying reverse characteristics, and we just I just introduced the topic breakdown. So let's discuss breakdown. Let's discuss the two types, right? So this is our diode. Negative, while the N side is positive. Okay. Okay. This is the junction, and this is the depletion layer. So what happens actually, because of these positive charges, the electrons are pulled out of the N region, while the holes are pulled out of the P region. So it's like the depletion layer spreads, right? It increases in width, as well as what else happens? The barrier potential as well as the electric field also increases, right? Now, from this point, it increases up to a point, after which what happens? A large amount of current flows, or large number of charge carriers, they travel, they cross the depletion layer, and which we say is reverse saturation, is reverse breakdown basically, in which large amount of current flows. We did all this, right? You remember we did this graph that, okay, this is reverse saturation and then this is breakdown. At a particular voltage, breakdown happens. So let's discuss why it happens. There are two possibilities of breakdown. Now, you already know that the majority charge carriers had been removed from P and N regions, right, by the battery. Okay, so only the minority charge carriers are remaining. So I'll mark the electric field as well. It is this. The barrier field is like this, while the external field is like this. Okay, since the external field is helping, the barrier width is growing in size, right? It grows up to a certain limit. So the P region has few electrons. Electrons are the minority charge carriers in this region. The holes are the minority charge carriers in this region. Okay, so let's say an electron comes close to the barrier, right? An electron comes close to the barrier. Okay, this is what? This is drifting effect. There would be no diffusion in reverse, arrangement, right? In reverse mode. Remember it? Diffusion was because of majority charge carriers, and it was due to difference in concentrations of electrons and holes on the two sides. Okay, it's like basically the electrons on one side try to level the concentration on the other side. So electrons flow in this way, holes in that way. Okay, small recap of what we covered actually. So another thing happens, which is drifting. The minority charge carriers move along the external electric field, right? Okay, so here the majority charge carriers are removed, and so only the minority charge carriers are available. Okay, so let's say this minority charge carrier, the electron, it reaches close to the depletion layer. This is the new width, right? Now just think about it. When it reaches very near to the depletion layer, because of very high barrier field as well as external field, what happens? A very large amount of force acts in this direction. Electron पे उल्टी force होगी. Okay, opposite force acts on electron. In this very small region, these very high electrons, this very high electric field, pushes the electrons to very high speeds. So they gather huge kinetic energy, right? Okay, even though width is small, they gather huge kinetic energy, because as I earlier said, the depletion layer is of the order 10 to the power minus 5. This is when the diode is not connected to a battery. This is connected to a reverse battery. Is it okay? So the barrier field is even higher, plus additionally external field. So it is 10 to the power 6 के order की field. Okay, high field means high kinetic energy for a very short duration. So now this high energy electron is moving through the depletion layer, Okay, let's say here it encounters a bond, silicon bond. Now since it is very high in it has very high energy, what, okay, this is like silicon, and this electron comes and damages the bond, okay, pulls an electron, and as soon as the electron is pulled out because of high barrier field as well as external field, this second electron also gathers very high kinetic energy very quickly. So now there are two high energy electrons ready to break two more bonds. 4 electrons would be there then after 2 bonds are broken. 4 electrons would be there. 4 high energy electrons ready to break 4 bonds. Then 8 electrons. This is a kind of a chain reaction, right? So from here you get 2, from here you get 2, then again, okay. So these high energy electrons, okay, it starts with